Hello everyone, welcome to this video. In this video, we'll be solving this question which states that suppose we have H as a non-empty subset of G, right? This is given to us and that it is given that it is closed under the group operation. Whatever operation G has, the same operation H also has and it is closed. So that means the closure property is satisfied within this H, right? And it has a property that if A is not in H, then A inverse is also not in H. So we are given that if A does not belong to H, it implies that A inverse also does not belongs to H, right? What we have to check? We have to check that whether H is a subgroup of G or not. So this is the criteria here, right? This is what we have to check. So in order to do this thing, we can utilize the subgroup test. So I say the answer is yes, it is a subgroup of G. But how this is possible, right? So I'll be giving you a complete proof of this thing, that how H is a subgroup of G, right? So let us suppose that A and B both belongs to H, right? Now if we show that AB inverse also belongs to H, we are done by proving that H is a subgroup of G. But before moving on to there, we have to first of all show that B inverse is also present in what? H, right? So if B belongs to H, we have to show that B inverse also belongs to H, right? So why this is so? Because then by the subgroup test, as I've told you, by the subgroup test, our A, B inverse would belongs to H, because we are given that H is closed under the group operation, correct? This thing is given to us. If it is given to us A is present in H, B inverse is present in H, then the composition is also present in H. So in order to do this thing, in order to prove this thing, let us suppose, if possible, let B inverse does not belongs to H, right? If that is so, we can utilize this given property. If some element is not present in H, right, by the given condition, so we can say that by the given condition, B inverse does not belongs to H would imply the inverse of this element is also not present in H. Let's have a look. Yes, this is what is the condition. So this would imply B is not present in H. However, this is a contradiction. Why? Because in the very starting we have assumed that B is the member of H, right? As B belongs to H, correct? Right? So using this thing over here, we reach a contradiction. So that means our supposition here was incorrect. Our supposition that B inverse does not belongs to H is incorrect. So this would imply that this implies B inverse has to be a member of H, right? If this is a member of H, whenever B is a member of H, so this, by the subgroup test, as I've told you above, by the subgroup test, we have AB inverse belongs to H if both A and B belongs to H. Hence we can clearly say H is a subgroup of G. So I hope you understood this question well. That is it for this video. Thank you for watching.